What has changed by using all this data, by analyzing all this data, by feeding these algorithms with all this data? What implications it has with our daily lives, with our way of looking at the world and doing business? Is that something different just by using more data, just by using these algorithms in everywhere? Does it mean that the world has changed so much? Yes and no. I will say that the way you should look at events for data have changed a little bit. Traditionally, scientists as myself used to have look at data in the causality relation. So everything has a cause, and this cause creates an effect, and there's a chain of events that you can track from origin. This is still in place in many universities. Unfortunately, this model is not absolutely correct or not very useful in the big data world. Big data doesn't care about causation. It cares about correlations. So the only thing we have is correlations. Just to give you an example, it was run a test by Kaggle, a crowdsourced machine learning platform, where we made a set of algorithms was run to determine what is the most important feature to determine if a used car was reliable or not reliable. It was the brand, it was the millenage, the age. What is the most important feature of a car that may assure the buyer that the car is in good condition? So they just fed the algorithms with the data. They have plenty of data from transactions in the US, and what comes out of the result was somehow surprising. You know what was the most important feature to determine the quality of the car? It is the color. If the car was orange, you may be assured the car is in good condition. And how do you explain an orange car is a good car? Why is that? What is the meaning of that? And the answer is there is no meaning. It's just a correlation. It's just something that is hidden in the data that does not come easily at just looking at the numbers, but the machines detect a pattern. And this pattern is a very strong signal. So this is an example where you somehow make a swap between causation and correlation. Also, data is messy. We are used to use SQL called the sequential query language, or structured query language, I'm sorry, to analyze all the data. If you have in the bank or telecom, you have very strict compartment where you put the data has to be in strict format. If it is a text or a number or an integer, everything has to be a right place. This is the world before big data. Today, you still use SQL, but you also use another paradigm called NoSQL or not only SQL, like MongoDB and other kinds of databases. And in these databases, we can deal easily with this unstructured data. Because today, when you create data, create information, you don't know what is the structure of the data you create. It just came from any sources that we may not expect. So data is kind of a live creature that lives outside our doors. We don't have it in our company. It's somewhere outside. And we have to have structures to gather this data and to analyze it and take value from it. Okay? So other thing that has changed is the fact that you shouldn't expect definitive answers. We are too much educated to get a white or black response to a certain answer, a certain question. In the reality is gray. So these algorithms are probabilistic algorithms. It doesn't give you, for instance, if you're receiving email, there is algorithms, machine learning algorithms for filtering out the emails if an email is spam or not spam. To do this filtering, the algorithms uses some probabilistic measure like the words that use in the text, how they are together, if they are links, the amount of links, so on and so forth. But the answer is never yes or no. There's a gray area, and you have to be used to live with this gray area. Okay. So another thing that this transformation have been inducing is the fact that we don't need too much theories as we used to need in the previous time. For instance, in the economy, people still loved predictions of economists about how the economy will grow, all these models, all these equations. In fact, these equations are useful. I as a physicist, I still use equations for lots of things, but the importance of these equations is becoming less and less notorious, because we can use the data at all its quantity. You don't have to have structures to work with few data. You can just you can simulate the full economy with all these agents, all these elements interacting between each other. We cannot do it now, but we can do something very close. So you don't need these theories, that some of them are wrong, to analyze complex systems. You can use just the data and the appropriate algorithms to simulate the event. So I will say that in terms of mindset, you should embrace this freedom, this openness of the data. You should not look at data as something that is my data, my company, my structure. No, let's consider data as some live thing, like some own desires, okay? And let the data live outside your doors. Because, as I will show you in the next slide, when you open your data, like the US government with initiative data.gov, when you open this data and you share the data to let others play with your data, the value you gather from that is much more than you are losing.